Hi, good evening, everyone. Welcome. Thank you all for tuning in tonight for another chapter of Conservation Conversations. My name is Ed Pritchard, and I work with Miami-Dade County, Miami Eco Adventures. We're a division of the Parks Department, and we're a co-host of this webinar alongside Anna Zangronis with UF-IFAS Extension and Florida Sea Grant. It's great to see some of our regulars here tonight, and for those that are new to this series, we welcome you. We thank you for taking the time to participate in this webinar series. Tonight will actually be our second in our exciting lineup of talks this fall, which, as a reminder, we host these every month on the second Wednesday, and that'll go through December before we regroup and announce our spring talks. You can sign up to receive emails regarding these upcoming webinars by emailing Anna. She'll put her email in the chat, and that way you can stay tuned for our upcoming talks. Just a few housekeeping items here before we get started with tonight's presentation. Everyone in this webinar is currently muted, and we would like to hear from you throughout the talk. So if you have any questions, the chat box is open. You can type those. If you go down to the bottom of your Zoom screen, you can see the chat there, and you can type those there throughout the presentation. And we'll go ahead, myself and Anna will curate those, and then we'll pose those at the end during our Q&A session. We also have some polls throughout this presentation, so we encourage you to participate. And also a reminder that this webinar is being recorded, and a link to that recording will be sent out to you in the next few days, so you can go ahead and share this great talk with others. If you enjoy these webinars, and this kind of content, please follow us on our social media pages at Miami Eco Adventures and at Miami-Dade Sea Grant. So with that said, I'm very excited to introduce tonight's speaker, Dr. Marybeth Arcodia. She'll be presenting tonight on hurricanes in a changing climate. So Marybeth, take it away.
Hi, everyone. Thank you all for coming, and thank you to Anna and Ed for hosting this Conservation Conversations series. So just a little bit about myself as we get underway here. I'm currently a postdoctoral research fellow at Colorado State University. My research involves observations, climate models, and machine learning techniques to understand sources of predictability within our Earth's climate system. And I recently finished my PhD at the University of Miami Rosenstiel School that you can see right here. And I finished this at the end of 2021. So to start with some questions before we begin today's webinar, we will go through, and these will be a poll. So first, what criteria are hurricane categories based on? A, size of the hurricane, B, wind speed, and C, pressure. Number two, what is the #1 deadliest hazard from hurricanes? A, storm surge, B, wind, C, rain, or D, tornadoes? And then number three, climate change is causing hurricanes to be stronger on average. True or false? So we'll have a few more seconds before the poll closes here. And just so you know, these questions will be posed again at the end, and you'll get to see the answers revealed.
We'll give it a few more seconds here, just to see if we have a few more. All right, we'll go ahead and close that now. Thanks, everyone.
Great. All right, so before we can start to understand how hurricanes will change in a changing climate, we first need to understand hurricane basics. So first, a hurricane is a type of storm called a tropical cyclone, which forms over tropical or subtropical waters. The energy in a large hurricane is about 100 times the world's electrical generation capacity. What this means is the amount of energy in an average hurricane equates to about 100 nuclear bombs. And another fun fact is that the top of a hurricane, right around where planes fly, is actually the coldest place on Earth at about negative 100 degrees Fahrenheit. However, hopefully you won't be finding yourself at the top of a hurricane anytime soon. So a little bit more about hurricane basics here. And just as a reminder, we're talking about Hurricanes the Storm, not our beloved Canes football team. A hurricane is a rapidly rotating storm system that has a low pressure in the center at the surface. It's a closed and near surface atmospheric circulation. It typically has strong winds, and a Category 1 hurricane is defined as 74 miles per hour or greater. It is a spiraling thunderstorm that produces heavy rains, and these spirals can even be seen from satellite imagery from space. So here's a look at tropical cyclones around the world, and each of these is a path of a cyclone from about 150 years altogether. Now, we have tropical cyclones all around the world, but they have different names. So tropical cyclones that occur in the East Pacific and the Atlantic Ocean are hurricanes, the term that most of us are probably most familiar with. Hurricanes or tropical cyclones that occur in the West Pacific are called typhoons, and tropical cyclones that occur in the Southern Hemisphere are called cyclones. Another thing that you may notice here is that hurricanes do not form on the equator. And this is due to the spinning force of the Earth that causes these storms to not be able to form at the equator, but instead to form right off of the equator and then move poleward. So a hurricane needs certain ingredients mixed together just right in order to be able to form. Luckily for us, we need certain ingredients in certain ratios, or else we'd see hurricanes all the time. So the first thing that we need is spinning winds or vorticity. And this also is defined by winds moving in different directions at the top of the atmosphere and the bottom of the atmosphere. We also need moisture in the atmosphere. And so this is what produces our rain inside the hurricane. And lastly, and most importantly, we need a deep layer of warm ocean. This warm ocean serves as fuel or gasoline for our hurricane. This is also why hurricanes typically form in tropical or subtropical waters where the ocean is warmer, and also why hurricanes typically form in the summertime and early fall when the ocean is at its warmest. So here's a satellite imagery of Hurricane Irma, which occurred almost 5 years ago to the day. And so what we see here is that the eye of the hurricane here is moving through the Florida Strait. But as this hurricane hits land, it starts to fall apart very quickly. And again, this is because it's no longer over the ocean or no longer having that fuel source to fuel the hurricane. And so again, when we see this satellite imagery, we see that while it's over the ocean, it's very strong, it's very well defined. Another cool thing about this satellite imagery is we see these flashes of light over land, and these are actually bugs that are lighting up the radar imagery at night. And so this is Hurricane Irma moving its way up the coast. So what does a forecaster look at? So this is a typical image of a hurricane that you may have seen on the news, and this is from the satellite. So this is a pretty standard view of a hurricane. What we see here is we see these spinning winds. We see a pretty strong eye. We see that it is spinning counterclockwise, as all hurricanes do in the Northern Hemisphere. And we also see some outward moving clouds. There's some clockwise rotating clouds off the top of the hurricane. However, what we don't see from this image are the impacts inside this storm. So where are the strongest winds? Where are the strongest rains? Where are spiral rain bands inside this image? So again, here's a satellite imagery of a hurricane, but a forecaster will look at infrared imagery to get more information about what's going on inside the hurricane. Now, using infrared imagery, we're able to see that it's the northern part of the storm that has the strongest wind, strongest rain. We can also see better these spiraling rain bands that are reaching far away from the eye of the storm. This is really important for impacts and forecasting, especially for people on land, if we're able to see where these greatest impacts are happening inside the storm. So now this is looking inside the storm. So imagine that you're standing next to a hurricane and we cut a cross section right through it. What we see here is first we have the eye of the storm right in the center. But what's surrounding the eye is the eye wall. This is where we typically have the strongest winds and the strongest rains. In the eye of the storm, we have downdrafts, and it's actually typically clear or more clear than the rest of the storm in this eye. But in the eye storm is where we have the strongest impacts from the hurricane. We then see these spiral rain bands as we move out, and it's characterized by upward and downward drafts as we move out. Eye walls can reach up to about 20 miles wide, but what's really important here is that the extent of the hurricane, and therefore the impacts from the hurricane, can reach far beyond the eye of the storm, out to sometimes 400 miles away from the center. The eye of a hurricane is an incredible force of nature. And here are two images from hurricane hunters, some of which reside at NOAA across the street from the Rosenstiel School on Virginia Key. And these images here show this stadium effect, this stadium eye wall effect from inside a hurricane eye. Both of these have clear skies in the middle because they were very well-defined and large eyes. But you also see that right outside of these clear skies is this eye wall, or this really ominous and very dangerous part of the hurricane. This image is from Hurricane Dorian, which decimated the Bahamas in 2019. And what's really impressive about this image is that it was actually taken from the ground. And this person was able to see the clear sky and this stadium eye wall effect from this hurricane. This is not typical in most hurricanes, but Hurricane Dorian stalled and was very slow moving with a very well-defined eye. And this is also why it caused so much damage. Another really interesting thing about this image here is that we see all of the damage came from the wind blowing one way, because only half of the eye had moved through this region. However, because it's a spinning storm, after the second part of this storm moved through, the wind actually blew the other way. And that's damage that you can see from both sides of wind damage from pictures after the storm completed its passage through. So one thing that we are probably all familiar with from living in hurricane-prone regions is the forecast cone. This is typically what you see on the news or in any sort of warnings when a hurricane's coming. So again, this is from Hurricane Dorian back in 2019. And at this point in time, it was projected to move right through Florida. But to understand the cone, we need to understand how this cone is made. So the cone here is showing a 66% likelihood that the eye of the hurricane will fall in that region covered by the cone. This is very, very important because this means that there is a 1/3 chance that the eye of the storm will fall outside of the cone. Also, what we saw from the previous image is that the impacts of a storm can reach far beyond the eye of the storm. So how to make the cone? Here we have South Florida. Let's say we have a hurricane right off the coast. So we run our very complex and very state-of-the-art forecast models, and we predict that the eye of the storm will be in this location one day later. However, we as forecasters are not perfect, and so we have error associated with these forecasts. And the error is typically, on average, 50 miles radius from this region. Now, as we move out to 3 days, the computer predicts that the eye of the storm will be here, but our error has grown because it's farther out in time. And now our error radius is 120 miles. We do the same for day 5, but our radius of error has now grown to 240 miles. To make the cone, we draw these radii, we draw circles around them, and then we connect the dots. So this is how your forecast cone is made. But again, this is only showing a 2/3 chance that the eye of the storm will fall within this cone. This means that there's a 1/3 chance that the hurricane will fall, that the eye of the storm will fall outside this cone. And more importantly, even if the eye of the storm is here, we could still be feeling impacts in South Florida from that hurricane. So it's important to use the cone wisely. But I did say that forecasters are not perfect, but they are getting better. So here, the purple is showing that the forecast cone from 2003. And you can see, especially as we get out to days 4 and 5, our radius of error was quite large. And so with many researchers on this, better observations, and better computer models, these forecast cones have actually shrunk. And so our cone size is decreasing and our forecasts are improving. But it's really important to remember there's still a lot of uncertainty, and the forecast cones are not impact assessments. So right now we are in hurricane season. Hurricane season runs from June 1st to November 30th. 114 hurricanes have hit Florida since 1851. So we've had a relatively calm season this far, but it is not time to let your guard down. And so now we have a good understanding of how hurricanes work, the impacts that we can have from hurricanes. So what does the future hold? How can we expect to see hurricanes changing in a changing climate? So what does a climate modeler like myself look at? So we take tons of observations from the past 150 years of data. We use these complex computer systems. They use the mathematical and physical equations that we know about our climate system. And then we're able to make projections of the future climate. So what does this mean for hurricanes? So to understand how hurricanes will change in the future, we can look at this through a hazards perspective. So these are some typical hazards, such as storm surge, wind damage, rain damage or flooding, tornadoes, which can actually occur far outside from the eye of the storm from those spinning winds, and waves and rip currents. So the surf is usually really good during an pending hurricane. However, it is very, very dangerous. And you should absolutely not be out catching the good surf when a hurricane is coming because of these really unpredictable waves and changing rip currents. So to look at these impacts in a changing climate, first we can look at rain. So for example, Hurricane Harvey in 2017 dumped a lot of rain on Houston. Why is this? It stalled out near the Texas coast. And so it gained a lot of water from the Gulf of Mexico, this fuel source. So it strengthened and also absorbed a lot of this water into the atmosphere. And then it stalled out over the Houston area and dumped this water. And so why this is an important example is because as our atmosphere warms, it's able to retain more water vapor in the atmosphere. And this means that there will be more rain available for hurricanes to rain out over land. Houston and the surrounding areas received over 5 feet of rainfall, which is catastrophic flooding. And so with climate change, we can expect to see more rain. Another major impact from hurricanes is wind. And so here, we are looking at Hurricane Floyd from 1999 and Hurricane Andrew from 1992. At the time that these photos were taken, both of these storms were Category 4 hurricanes. Hurricane Floyd ended up moving up along the coast and hitting more of the mid-Atlantic region. Hurricane Andrew, as many of you are probably aware, strengthened into a Category 5 hurricane and moved right along South Florida, causing catastrophic damage and especially devastating the Kendall and Homestead regions. We actually just had the 30th anniversary of Hurricane Andrew a few weeks ago. So while these storms are both Category 4 in these pictures, they are also very different sizes. And so again, just looking at the size, just looking at the category of a hurricane doesn't necessarily tell you the impacts. But since we know that the ocean is fuel for the hurricane, then as our ocean continues to warm, this means that there's more energy available for the hurricanes, which means that hurricanes on average will likely be stronger because of the warmer ocean that they are moving over. So climate change not only means more rain, but stronger hurricanes. As a note, hurricane categories are based solely on sustained wind speeds in the eye wall. And so these winds can be very damaging, but these are not the only hazards from hurricanes. And so category of a hurricane is not the sole impact that you can expect to see from a storm. And so why it's so important to stay inside during a hurricane is winds can cause flying debris down power lines, down electrical lines, and again, very dangerous. And so in a changing climate, we don't necessarily expect to see more hurricanes in general. We don't expect that hurricanes will get more frequent, but what we do expect is the ones that do form will be stronger. So less of these tropical storms and Category 1, 2, 3 storms, and more of these Category 4 and 5 hurricanes. And then next, storm surge. Storm surge is the #1 deadliest threat from hurricanes. Storm surge is caused by water being pushed onto land by wind from the hurricane. So this is different from flooding caused by rain, because instead it is actually the powerful winds from the hurricane pushing the water onto the land. And what this means is that the sea level or the water level on the streets can raise by feet in a matter of minutes. This means gushing water and very dangerous. And so why this is important for climate change is because its storm surge is tied to sea level rise. So this is the storm surge that we saw from Hurricane Andrew in 1992. We can see that a good portion of the coastline was inundated by storm surge, with these coastal areas receiving over 12 feet of storm surge, and a good part of Miami-Dade County receiving about 9 to 10 feet of storm surge. However, in a changing climate, the sea level is rising, and the sea level is rising along the South Florida coast at a higher rate than the global average. We're seeing a very accelerated rate of sea level rise right off of our coast. What this means is that the baseline sea level is now higher for when hurricanes move across to push that water on land. So if the same hurricane moved across South Florida, but now with 3 feet of sea level rise, this would be the storm surge from the same storm. Now we have overcome the ridge that moves through the Coconut Grove area, and the entirety of Miami-Dade County is inundated, with now some regions receiving up to 20 feet of storm surge. So what does a warmer climate mean for hurricanes? Climate change, we can expect to see rainier hurricanes, due to the warmer atmosphere absorbing more water vapor. We can expect to see stronger hurricanes due to a warmer ocean that's fueling these hurricanes. And we can expect to see higher storm surge because of a baseline sea level being higher. And while we don't necessarily expect to see the number of overall hurricanes to increase, we do expect that the ones that do form will be stronger. So this isn't great for us, especially in a hurricane-prone region, but there's still a ton of questions out there. This is an active area of ongoing research, and the impacts are still very important to be heeding today. It's also important to remember that when we look at hurricanes through a climate change lens, we're looking at how hurricanes on average, in general, will be changing. No one hurricane can be attributed to climate change. But what we can see is changes in general to these hurricanes. Also important to remember, we are currently in hurricane season. And so as stated before, we have had a relatively calm season so far, but the peak of hurricane season is typically in September and October. And actually this week that we're in right now is on average the peak hurricane season for the entire Atlantic. We also see here the accumulated cyclone energy that has a huge spike mid-September. So not time to let your guard down. But we also have been spared recently, especially in the Miami region, from hurricanes lately. The red here is Hurricane Matthew in 2016, which caused a lot of damage to the Bahamas, but minor damage along the Florida coast. In green, we have Hurricane Irma, which at one point was projected to hit Miami dead on, but eventually moved west and caused significant damage to the Keys and the west coast of Florida. And still, even though we missed a direct hit, Miami still sustained damage. And then lastly, Hurricane Dorian in 2019 also took a curve at the last minute. We still felt impacts, but not a direct hit. This in no way means that we should let our guard down for this season. As the National Hurricane Center aptly puts it, it only takes one storm to change your life and your community. So it is very important to be prepared. And so it's also important to remember that those people who are already vulnerable to the effects of climate change are most vulnerable for the impacts to be hitting them. So while hurricanes can hit anybody, anywhere, the impacts from hurricanes and additionally the impacts from climate change and hurricanes disproportionately affect our populations. And so it's important to be prepared and to take the necessary precautions to the greatest extent that you are able to take them. So some things to do here are to get bottled water and canned food. The recommendation is to have 1 gallon per day per person in your household. You also want to have food that is non-perishable and easy to open. Stock up on medicines that you need as well as a first aid kit. Make sure that your cell phone is charged and if possible, have a portable charger in case your cell phone dies. And to have a flashlight and a radio and extra batteries. If the power goes out and your phone dies, the radio will be the way that you can get the best and up-to-date information. If your water goes, one thing to do before your water goes out is to fill your bathtub with water. And while this water is not for drinking, you'd be able to bathe yourself or potentially flush your toilets if you lose power and water for a number of days. Lastly, evacuate when told to do so. If you stay in a mandatory evacuation zone, this means that first responders, meaning police, ambulance, and firefighters, are no longer required to get to your house or your community. And so this is now putting additional people at risk if you stay in a mandatory evacuation zone. However, it is known that not everyone can evacuate. And so if you are not able to evacuate, you need to let somebody know that you are staying, to let them know how many people are in your household, and any needs that you may have. Another option, if possible, is to find a shelter nearby. The climate change and the hurricanes in a climate change the hurricanes in a changing climate can be very doom and gloom. However, there's room for hope and there's room for optimism. And so there's ways that you at home can help this situation. And so one of the phrases that we hear the most is reduce, reuse, recycle. And so you can actually do these things in order. And so first is to reduce the amount of consumption, especially plastic consumption. So use a reusable water bottle, use reusable shopping bags when you go to the grocery store. If you do acquire a new product, then reuse it. For example, a plastic bag from the grocery store, use as a trash bag. And then lastly, to recycle. If you're not able to reduce or reuse, make sure you're at least disposing of your trash or recycling if possible. Again, reusable water bottles, reusable bags, turn off the water while you brush your teeth, turn off the lights when you leave a room, and importantly, do not litter. If you throw trash on the ground, there's a very good chance it'll end up in our beautiful oceans, which not only can harm marine life, but can also pollute our oceans that are not only beautiful to look at, but beautiful to swim and spend time on. And so there's lots of things that you as individuals can do. And it's always important to remember that small actions can have a big impact. So now to go back to those questions that we asked at the beginning, I will talk through these again, and then we'll move on to the answers. Okay, so the poll just came up. Number 1, what criteria are hurricane categories based on? A, size of the hurricane, B, wind speed, C, pressure. Number 2, what is the number 1 deadliest hazard from hurricanes? A, storm surge, B, wind, C, rain, D, tornadoes. And then number 3, climate change is causing hurricanes to be stronger on average. True or false? Ed, I'll have you let everyone know when the poll is wrapping up.
Well, let's give it a few more seconds. People are starting to fill them in. Thanks, guys, for participating. All right, I'm gonna go ahead and close that.
All right, time for the answer reveal. So hurricane criterias are based on wind speed and wind speed alone. These are based on the sustained winds in the eye wall of the hurricane. And so categories are not impact assessments. And so even if we have a low category, say a tropical storm or category 1 storm, these can be carrying lots of rain, and still those wind speeds can be very damaging. But hurricane categories are based on wind speed. The deadliest hazard from hurricanes is storm surge, and this is due to the rising waters very quickly, which can cause these gushing waters in areas where people live, which is very dangerous if you're outside, but also the force of this water can actually damage infrastructure. Number 3, climate change is causing hurricanes to be stronger on average. That is true. Again, no single storm can be attributed to climate change directly, but the background state of a changing climate is impacting hurricanes in general. And so we do expect to see not only stronger, but rainier hurricanes with higher storm surge. And so that is my presentation for you all. Thank you so much. Here's my email address if anyone has more question or wants to reach out to me, and I'm happy to take questions.
Great. Thank you so much, Marybeth. That was really, it's starting
I'll
to come
turn on
down.
my camera for questions.
Yeah, so we really appreciate that and enjoyed that presentation a lot. It's now past 6:30, so if you have to leave, that's totally fine. But we're gonna stay on. We're gonna, if you guys have any questions, we're gonna go ahead and pose those to Marybeth. Let's see, and you can go ahead and type those in the chat, and myself and Anna will take turns posing those.